Hi everybody, this is Jennifer Phillips-Russo, the Viticulture Extension Specialist for the Lake Erie Regional Grape Program. Here we're housed at the Cornell Lake Erie Research and Extension Laboratory in Portland, New York. And part of the research we do during the dormant season is bud hardiness. We're part of a grant where Tim Martinson, who is Cornell's State Viticulture Extension Specialist, is the primary investigator on it, and myself and other viticulturists from Cornell across the state are also collaborators. So in the past, what we have done is we've done our bud collection and then shipped them off to Geneva, and they had their freezer there and did all of the bud hardiness research there. But on this last year's grant, we actually were funded to get our own freezer here so that we can help take off part of that load, because it's statewide that everybody was sending stuff off, to help take on some of that research and do it right here. And then you can have, if you're part of the Lake Erie Regional Grape Program, up-to-date information and our CREP updates as well. But I just want to give you a brief overview of what that is. So we know that we're a cold climate here in Western New York in the Lake Erie region. And that climate tends to vary throughout the years. And sometimes we get super cold. And when things like living tissue, everything contains water, that freezes, and it can be detrimental to the next year's crop. Bud injury is a big thing around here, especially if you have hybrids and vinifera. So this work actually does both natives, hybrid, and vinifera, and you can find, I believe it's the last 8 years of information out on the website. I provide it below, and also the Lake Erie region information is out there as well. So the process that we go about doing that is we have this 10E2 freezer. It is connected to a multimeter, or this Keithley meter here. And then we have these trays. Brock University has developed a software, which is Bud Processor and Bud Freezer and Bud LTE. So what we're going to do is our buds, this was talked about in the last crop update, I believe. All of our buds, we have compound buds. So there are 3 separate buds inside of that fruiting material for next year, basically next year's crop. There's the primary bud, secondary bud, and tertiary. So the primary has the most already preformed flower clusters that could then potentially turn into your crop. It also contains the most living material. So it is basically the first to freeze and die if we have super cold temperatures. Then you have the secondary bud, which has more preformed fruit flower clusters, but not as much as the primary, and the third or tertiary bud, which is basically just a shoot. So in this region, you know that we can have death of vines and death of buds. So knowing this information of the bud hardiness allows us to have a tool that when we graph it with the high and low temperatures, you can see on the graph if this lethal temperature, which is the temperature of which the bud dies, if it goes below our low temperature, then you should be going out and assessing your vines. So that way, if you leave up more buds in the winter, so you can adjust your pruning levels in the spring, which is really actually a handy tool, and I'm very proud to be a part of this project. And now having this freezer here in-house at Lake Erie in Portland, New York, is going to help us do more research, not just along the lines of the bud hardiness with Tim Martinson. So I'm excited for what we can do in the future with this. But I want to show you the process that we actually do. Here we are at the Cornell Lake Erie Research and Extension Laboratory. These are our research vineyards. We're looking here, this is actually the block that we validate sensors in, but they've graciously left me this first row for pruning for my bud hardiness work that we're working on as well, in conjunction with the USDA and other Cornell scientists and viticulturists across the state. We're collecting information to see about bud mortality and just how low of a temperature we can get to, which is actually changing and fluctuates with the weather as well. So the work we do is we come out and we take first year canes. So the important part is that we're concerned about next year's crop. So we want to leave the wood that's actually going to have the buds on it. You want the first year wood that matured this year. I'm going to count out, leave a couple buds. I usually leave about 4 here for the Concords and then take my sample. We're not just doing Concords here for this particular study. We're doing 4 varieties. We're doing Traminette, Niagaras, Concords, and we're going to walk over and get some Riesling after this. So now we're in our Riesling block. And I'm going to leave about 4 buds on these spurs as I'm walking through. Making sure I get enough to freeze. It's better to have 10 buds in each cell. There's 9 cells that we're going to use. I'm going to show you the trays when we get back up there. 1, 2, 3, 4. Sometimes they don't play very well. All right, that should be enough. You saw earlier that we go out in the vineyards and we collect the buds. This season, which is the 2019-2020 season, we are actually testing 4 varieties. We test for Concord, Niagara, Traminette, and Riesling. So we have natives, hybrid, and vinifera in there right here at this station. When we get back here, I need to cut the buds, which you'll see in just a moment. You need to make sure that you get just bud material because any living material contains water. And that means if there's water in it, it can freeze and die. So you want to be careful not to get part of the vascular bundle when we're doing that because it can show you or not really mess up your readings, but it's just going to require you to be a little more diligent in what peaks you notice. So I mentioned peaks. What happens when water freezes is it lets off this peak of energy, its last spike of energy, which is heat. That heat can then be recorded as a temperature spike through our multimeter. And then that information can be brought into our software from Brock University, and we can figure out what the lethal temperature or the LT, lethal temperature exotherm, is. And that's how you can have that information to help you as a tool in your pruning process. So here in our trays, you can see there are 10 cells. We actually only use 9 of them. It's a foam insulator. These are cells. These are from the last run that we did, last week's information. All the buds that are collected. Okay, so just for a real quick overview of what we do, we've gone out and collected our buds. I'm going to move all, these are the 4 different varieties. Move the 3 that I'm not going to work with out of the way as of right now. We'll start with Concords. You need to take your dormant canes with, what you want to do when we're out there taking it is I want to take buds that are actually representative of this year's growing season of what is in. So I take the 1-year wood, one bud, we cut the buds off. See, this one has a little bit of the phloem or the vascular bundle underneath it, so I don't want to throw off my reading, so I'm going to trim that off. And we end up filling our cells. Put a little chem wipe in there. I give it a little spritz of water to sort of help make that connection because when I place these buds in here, I then use this little foam pad, and that foam pad is insulation. You can see all of the wirings hooked up in this harness here. This center cell is what's called the thermocouple. That has all of the information that reads the temperature spikes from each one of these 9 cells and then delivers it to my multimeter over here and then into our software process from Brock University. So we're going to put all of our buds in here. Then we load up our machine, our trays. And we put it into our freezer and connect everything out. I'm not going to do that right now because I have a lot more buds to cut in order to have this run ready. But after that, we plug it into the Keithley. This particular freezer starts at 4 degrees Celsius and sort of ramps down from there. So it takes a reading from these cells every 15 seconds as the temperature is decreasing. And as soon as it hits that lethal temperature, that kills the bud, it sends out the spike and records it. That information is then downloaded into this software. So after my run, and it's an overnight run, I come in the next day. I always tend to zoom in a little bit more. See how we have this? These are the temperatures along the bottom. We have 0 here to -40 over here. Voltage. I zoom in and you can see peaks are starting to form. And what is really cool about this is then I can go through and get a more clear picture of these peaks. And then I do what I call the peaks. So we can, this is where you're going to have a little bit of trickiness, and it takes some time to get this figured out and sorted out, because these are primary peaks, these larger spikes, and that's because it's more material in that primary bud. Then we have secondary peaks, which are smaller spikes, and it gives off less heat because there's less water in those secondary buds. So you have to be able to differentiate between your peaks to be able to call that out. I then take all this information and we graph it, and I send it off to Tim Martinson in Geneva. And it's actually on the Cornell website for grapes and wine. And you can go back, like I said, and see the last 8 years worth of data out there up to recent data that was posted last week. So that's part of the research that we do here, all to help our industry and helping make decisions for maybe delayed pruning and winter assessment, bud injury. If you have any questions or comments, please feel free to list them below, and we will see those and address them appropriately. Thanks, everybody. Have a great day.